Folks, good afternoon, everyone. Yep. Okay, we had a tea break, I know, so I need more energy. Okay, good afternoon, folks. Okay, so this is my first time in a Kochi, and it's been I can see the lovely energy. People are so. I mean, there's a lot of technical discussion is going on, so it's great to be here, and it's my privilege to presenting the first time in the ACD Kochi. So it's great. So my name is Ashish. I am a developer advocate at Elastic. Okay, so some people know Elastic with Elasticsearch, ELK. Okay, and so just wanted to get start with this question. Who know Elastic? Yeah, you can just raise. Elasticsearch. Okay, ELK kind of stacks, right? All right. So I mean, if you don't know, I'll tell you how you are using Elasticsearch in your day-to-day life. Okay, so everyone has booked the Uber cab, right? So when you type the location and it shows the cabs available near about your location, that queries goes to the Elasticsearch and give the result. So Elasticsearch is capable to handle the geospatial data types of data. It's give the full text search. So when I say the full text search, anyone, what is the full text search? Okay, who will be the answer? I have a special goodies for them. So please, what is the full text search, folks? Yeah, ma'am? Yep. All right, perfect. So when you type something searching on a Google, it's like what is the elastic? So it's going to cut your sentence into the tokens. What is an elastic, right? And it's going to search independently, right? This is called the full text search. This is how your search, when you search on a Google, Yahoo, any traditional search engine, whether it's a Swiggy, Zomato, the search box, this is how it works right now, correct? Now there's a search has been evolved. Okay, so I'll give you the example. Sometimes you don't know the context. Sometimes it is happening. You have to search something, but you don't know the exact keyword, and you start typing the context around that keyword. But yeah, you get your desired result, right? It's happening. So this is called the semantic search. Okay, this is achievable by using the Elasticsearch. So I'll go through the more, but today we are going to talk on the RAG. Anyone, what is a RAG? Retrieval augmented generation. Okay, which is good. But we will see what is the RAG and how you can use the Elasticsearch as the best RAG system, correct? So let me, okay, yeah. So who think since LLM, the chat GPTs and all those, the big LLM players are in market, the search is not important. I mean, who is using directly chat GPT to search about some errors, to writing a codes, okay? But so you have completely stopped using searching on a Google or Stack Overflow. You have completely stopped? No, right? So search is still important, correct? Anyone know why? We're having a LLM who's capable enough, but why search is important? Okay, let me give you the few examples. Okay, you must have gone through this news. The lawyers use the chat GPT to file the court case, and the judge corrected him. So sometimes it gives you the hallucinated result, right? The LLM can hallucinate you. Okay, the accuracy of result is not that up to the mark, especially if you are talking with the private data, correct? The public LLMs are not trained on the private data set. Agreed? If I'm going on a chat GPT and I'm going to ask who is Ashish, of course, you don't know because it's not trained on that. But still, if you want to build the question answer capability, this is where the RAGs comes in a picture, and you can create the question answer or chat kind of component on your private data set. Okay, so for this you don't need to you don't need to train any model. You don't need to put any extra effort. This is where the RAG comes in a picture. So I'll give you the example how actually it looks like. Okay, so LLM need to be grounded, of course. I mean, LLM is not grounded. So when we say the grounded, it don't hold your real-time data, private data, kind of this. So how we can overcome? But yeah, before that, Elasticsearch, why Elasticsearch is the best RAG system. So this is one of the few feature we have. So Elasticsearch you are mostly using for the logs, I guess, right? Log search. Okay. So anyway, so you have used the Misho. Anyways, use the Misho.com. So when you search, that query goes on Elasticsearch and it gives the result. It is best technology for the search. Similarly, I can tell you the Wikipedia or Bajaj FinServ. So vector search, they are also using the vector search, full text search, and vector / semantic embedding. These are the same terms, semantic search, right? So Elasticsearch also give the geospatial data type. So you just insert your latitude, longitude data, and you can perform the shape query on it. So shape query when say within a 5 kilometer, give me the record, within a 100-meter radius, within this particular triangle, polygon kind of shape. So similarly, it provides a columnary data, heavy analytics. I mean, Elasticsearch is proven a great search engine which is available for free from the years. And it is possible because of the stacks, elastic stacks, right? So this is the fundamental, there is 4 stacks which is called Elasticsearch, Beats, Logstash and Kibana, which is the ELK, correct? And on the top of it, we have built the solution like observability, security, correct? So Elastic Observability is also free. So if you want to perform any kind of the monitoring, observability, whether you want to monitor your code, distributed tracing, APM, you want to monitor your infra, the servers, right? The Kubernetes cluster, Docker. You can just, it is just single agent installation and your monitoring, your dashboard will be ready within a minutes. So you can just give a try if you wanted to do. It's available in the community edition also, right? So, okay, I'm happy to take a more discussion on this because today's topic is more of the LLM and the RAG, so I want to focus on there. So, okay, but before that, AWS plus Elastic, what we have an integration. So we having a good service monitoring of AWS, whether you wanted to do the cost analysis, how much of VMs are running, my S3 consumption, the Lambda consumption, everything you will get in on the Elastic Observability. Similarly, if you have a CloudWatch logs, right, you generating a lot of logs and you want to get into the Elastic for a full text search and building the more analytical view, you can use this Elastic Observability. And yeah, Elasticsearch is using the snaps for a snapshot and restore the S3. We are a very heavy user of the S3. Similarly, the Bedrock, which I'm going to show you in the next slide, how you can use the Bedrock as a, what is the Bedrock, folks? I think, sorry? Okay, anyone else? Bedrock, serverless, it's model kind of runtime, right? Foundational model, correct? It is not similar, but it's kind of like a ChatGPT or a Vertex AI kind of. It's give the list of model, you can use it, okay? So, let's talk on a more retrieval augmented generation. What is the meaning of that actually? And anyone want to give a attempt? What is a RAG? Okay. Okay, this is one of the examples. So I was just searching on a ChatGPT, where is the AWS HUGKOCHI event is happening, right? Of course, it don't have a data. It's not trained on that, right? But now assume you have a private, you are a bank, and you have your private data set, and you want to provide the question answer capability to your client, correct? On the private data set. So how you can do it? Of course, you cannot go and train the model, right? Training the model is a very costly and time consuming. It is not that easy. It requires a huge infra and a cost first. Second, it need an effort, correct? It need a different level of expertise. Okay, now same situation is with ChatGPT, correct? But I can provide the context window to the ChatGPT and it will give the result. So the context window, when I say, I can simply change my prompt, like answer the question based only on the following context. I have provided the context, hard code. Okay, I have given the context now about the AWS user group and blah, 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 everything. And then I'm asking the question. Something wireless? Sorry. Hello? Okay. No worry guys, it's a technical issue in technical event, it's happening. So Okay, so now the question is where is the AWS HUGKOCHI event is happening? Now ChatGPT is able to answer because I have given the context window. Now you will see, okay, we can provide the context. What is the big deal? Isn't it? I mean, it's may looks like a foolish. I have already answered this question, but the giving the context, okay, it led the LLM model to give the more accurate result. I'll show you how. Now assume you have a terabytes of data, like the banks, right? And your client is coming and he's writing a question like, what is my food expenses last month, or what is my shopping expenses last month, right? At that time, you need a RAG. You have to provide the context window and plus prompt, and then you can send to the LLM. I'll show you in an example. Okay, so picking a proper context is a challenging. So everyone got what is a context, right? So here, which I have provided this is a context. It is a just text information about my question. I have asked to the ChatGPT, I mean, just give me the answer of this question from this context, and ChatGPT is giving this answers. Correct? Now this answer looks more accurate than this, because, right? So why context window is so important? Because you give the context information, and ChatGPT will apply its intelligence. The LLM model will apply intelligence to extract the actual relevant information, that context window. But you have to provide the context. That is the thumb rule, okay, for your accurate result. Now, suppose I want to build some question answer capability on my private data set, and I want to give the look and feel like a ChatGPT only, but on my private data. And for that, I don't want to train any model or something. This is how you can achieve. So this is where the Elasticsearch comes in a picture. So Elasticsearch, you just dump your all private data into Elasticsearch, okay. Now Elasticsearch is a well-known technology for search, for the relevant search, correct? So whatever the query you're going to hit on the question, your user, it will go first on the Elasticsearch. So suppose, what is the AWS Kochi? That question will go first on Elasticsearch. Elasticsearch will provide the relevant result, the first top 2 or 3 document, and that 2 or 3 document will go as a context window. So here, my context window will be directly replaceable, whatever the result I'll get from the Elasticsearch, right? Is it good? Okay. So once you got, then you keep the prompt as it is. You can change the prompt according to your use case, but this is a very basic example I have taken. Now you just give the whole prompt to the LLM, which is a Bedrock, and Bedrock will give you the right answer. Okay. So if you're asking the question without the context, it will hallucinate you, or definitely 99% your private data set will not available to the LLM. Definitely, it's not trained on that. Okay. So let's take a example on this. Okay. Okay. So this is a demo. Unfortunately, I cannot show you here, but I'm more happy to show you on my booth. I have plenty of demos ready. So here I have asked what is the work from home policy, and first this query will go on Elasticsearch, and from the Elasticsearch it will come with this result, which is a more relevant result, and then I'm going to club this both together, question and context, and going to send to the prompt to the Bedrock. So my prompt will be like this: answer the question based only on the following context. The context will be from Elasticsearch and the question, and I'll simply pass to the Bedrock, correct? Now, you can easily replace this Bedrock with any LLM, probably OpenAI, ChatGPT, Azure OpenAI, AWS Bedrock, anything. It's up to you. Because every LLM having this limitation, the hallucination and the data restriction, the data privacy, right? So, yeah, you can just send to the Bedrock. Bedrock having the good list of models. You just pick according to your use case, and at the end you will get the accurate result. And now this is how you can build the, ChatGPT kind of experience, right? you can simply set up all this on your private data, and you can give the chat window to your client. They can directly ask the question on your private data set. You don't need to, you don't need to train the model, you don't need to add a cost, anything. It's just that much. So, any question, folks, till now? Okay. Now, one question from my side. Why Elasticsearch? Okay. This I can replace with any database, like a MySQL, Mongo, or anything. It is just a one query. I have to get a result and provide the context window. But why Elasticsearch? Because Elasticsearch is a well-known technology for the fetching the relevant result, correct, with full text search, right? It is also provide the vector search, when say the semantic search, right? And also it is provide the hybrid search. So always doing the semantic search or the full text search is not enough. It is the best recommendation is you do the hybrid search, full text search plus semantic, correct? So semantic is nothing but it's just not searching on the keyword, but it is also searching on your meaning of that keyword. So if I say the beautiful, what we can say, actor, actress, probably it's going to search on best actress or good actress, kind of the synonyms, correct? So this is what we call the semantic search. And Elasticsearch having the capability for both full text search plus, what is the time, folks? Okay, so Elasticsearch is having the capability on this. So you can do this. Apart from this, right now, of course, there is a lot of vector DBs are available, but just having the only vector storage is not enough. You need the simple search, the BM25 keyword-based search plus vector search, right? On the top of it, you can perform a lot of, the analyzer, tokenizer, the language. You can do the multilingual search. If you have a multi-language, you want to. So one of the Kannada government is website is running the Kannada analyzer they are using, and they have built the search engine by using Elasticsearch. So they search on a Kannada language, right? So if you want to build any language search engine, Hindi, Marathi, kind of, you can just go and check with the Elasticsearch language analyzers. So on the top of it, you can come with your own business use cases, application, and everything, and it will give you the exact proper context, right? So what is time? Okay. So I think any question, folks, till now? Anyone is using vector search? Vector search you are using? You are using. I mean, if may I ask, which tool? Okay, the F5, ChromaDB, yes. So yeah, you can give a try to the Elasticsearch. It's having the wonderful support. Apart from this, the observability, security, if you have a malware detection, the endpoint security, everything, you can just go and check. So yes, everything is available, which you can see is a free edition. Okay. Of course, in a cloud, we offering the ELSER model, which we having our proprietary model, ELSER. So now, when you generate the embeddings, the vectors, so you must be using some LLM like from the Hugging Face, or kind of this. Now we having the ELSER model, which generate the sparse vector. Now there is a difference between the dense vector and sparse vector. So dense vector, you must have seen the numerical value. If you give the text, it will give you the large number of the arrays, float numbers, right? That is called the vectors. But here it will going to generate the same context words, English words. So I suppose I am giving the good, it's going to generate the best, beautiful, or whatever the contextual meaning, right? So sparse vector is much powerful, much faster. So the generation of the embedding is quick in a cloud. So that is a difference. And in a community edition, you have to generate embeddings, and then you have to store. In a cloud, the generation can be on fly, so you don't need to worry about it. Yep. All right. So okay. So this is how you can just do the flow. I have a demo ready on my booth. So I'll invite you all to come and just have a look to the demo. I have a vector search and difference between the vector search and the keyword-based search. So you can just come and check how it looks like, correct? At the end, I just wanted to leave you guys with these resources. If you want to get started with the generative AI with the Elastic as a free on the community edition, just go through these links, and we're having a wonderful set of examples ready, so you can create your own RAG, Readable Augmented Generation system. So with this, I think, yeah, I'm good, I'm done, and thanks to being a lovely audience. So I'm open for a question if you have any. Any questions, folks? Yep. Yes. So when you capturing the, how the embedding is going to store. Suppose heading, there is a key value, key name is heading, and the text. Yeah. So you can give the key name according to your use case. Probably I can give heading underscore embeddings, and I can store my all embeddings on that field. Yeah, you have to tag, your embedding will going to store into same JSON document only. No. So while you're inserting, it is a JSON store, right, in Elasticsearch. So in a JSON, suppose your one record represent the one JSON record. In that JSON record only, you introduce new field as an embedding, and your all embedding will store there. And it's up to you how much field you want to introduce. It's up to you. So for the mapping, while creating the schema, you have to define that the type. Right, the type is a dense vector. Yeah, anyone else, folks? Okay, so I'll invite you all to the booth, and I have a demos ready. I'm happy to have a discussion over the semantic search, Elasticsearch, or anything about the Elastic. So thanks a lot, and thank you. Yeah.
Thank you. Thank you, Ashish.
Yeah.